This is pretty easy, right? A meteor entering into the Earth's atmosphere, burning up and scattering into many fragments, and finally getting converted into ashes. But the problem comes when you have to slowly come into the Earth's atmosphere and get back to the ground safely. So, why not fly like a helicopter or a drone and get back to the ground slowly? For this, we must have a huge amount of fuel to counteract the gravity of Earth. This is not at all a good option because let's assume fuel prices are very cheap, but to carry that much amount of fuel is not possible. So, what other options we have? We can reduce our altitude by reducing the speed and descend very slowly and get back to the earth. When you descend and enters the earth's atmosphere and assuming you have a perfect glider shape to glide into the air, but the air is so thin that lift will not produce. So the glider will not fly and will perform a free fall. And as the altitude decreases, air will get thicker and thicker. So the glider can produce the lift and land back to the earth just like an airplane, but without the engine. So the most difficult thing in this journey is from the altitude of around 400,000 feet, which is around 122 kilometers. At this point, we can say that re entry has just begun. It depends on the spacecraft how much time it will take to touch the ground. For example, it took around 13 minutes for Apollo 11 to touch down, whereas 26 minutes for the space shuttle. At the time of re-entry, the speeds are much higher, around 25 times the speed of sound. During this time, vehicle is under high thermal stress due to the friction created between the body and the atmospheric air. Heat is so intense that it can melt any metal, any alloy, and turn them into plasma. So, how do we minimize this temperature? We make surface with curved edges. Yes, we don't use pointed fronts. A perfect aerodynamic body like fighter jet has a pointed nose to reduce the drag and achieve huge speeds. We don't want to accelerate, but we have to deaccelerate. So the big surface area will provide drag to slow down the spacecraft, but we still have heat generation due to the friction. To reduce this problem, we have a curved surface and not the pointed ones. Whenever we travel the speed greater than the speed of sound, shock waves are created in front of the body. Due to shock wave, speed of the air coming from front will reduce drastically after crossing the shock wave, due to which huge heat is generated. If the shock wave is attached to the body, all the heat will be transferred to the body. But in this case, we use a curved surface. For example, Russian Soyuz. It has a curved bottom and with huge surface area. So now we have a detached shock wave, or it is also known as a bow shock wave. In detached shock wave, there is some gap between the body and the shock wave. So whenever heat is generated, it will dissipate it to the atmosphere, but still some amount of heat is passed to the body. But this heat is also very huge. So now to withstand this heat, we use silicon plates or carbon-carbon composites on the aluminum body to withstand the high temperature. There are huge temperature outside the spacecraft and plasma can be seen from the windows. Temperature is the main reason it's very difficult to re-enter into the Earth's atmosphere because we cannot use heavy metals to withstand the temperature due to their weights. So we go for composites which are lightweight with thermal and structural properties.